Bismillahirrahmanirrahim. Assalamu alaikum. I am Adil Abbas from knitting 6th semester. Today here to present about the computer controlled parts of complex stocking machine and possible damages on wrong commands for mid semester assessment of computer applications in engineering design. Here are the contents of presentation. First of all, introduction, then computer controlled machine parts, and at the end wrong command damages and conclusion. So let's start. What are compression stockings? Compression stockings are the special hosiery designed for providing better stretch and recovery properties and compression than normal hosiery. These work by decreasing their circumference as moving toward the feet of wearer to provide the compression. Purpose of compression stockings are following: to improve the blood circulation in leg and other body parts, to prevent the blood clots and leg swelling, and for treatment of burn wounds. Merz software and compression stocking machine. Compression stocking machine is a fully Jacquard machine on which compression stockings are manufactured. These fetch data from Merz programming modules. Here the current machine version is C4II, so the programming module is Merz C4II programming module. The software consists of machine parameters which are to be adjusted in the form of rows and columns format in order to fed data to the machine. Here is a general layout of Merz C4II programming module that it consists of a standard column, step, yarn finger plus and yarn finger minus column, clamp plus, clamp minus column, step motor column, feeder column, heel and pattern column. There are some other columns which are not visible here. We will discuss those columns in the presentation, which are associated to some mechanical parts on the machine during manufacturing of a normal stocking. Mechanical parts of a machine controlled through computer. As compression stocking machine is a fully Jacquard machine, so a proper software is used for its operation. All the mechanical parts are controlled by software which are involved in knitting and other activities, while only main motor gets drive electrically and provides drive to the mechanical parts. Similarly, pneumatic systems are used to assist the computer fed commands which are to be executed on a machine. uh, this is a general layout that we enter value in the feeder, and this acts on the furniture present on machine and controls its rotation with respect to the rotation of cylinder of machine. Rotation of cylinder. Cylinder is a basic part of compression stocking machine, which consists sticks in it and needles are mounted on it. The RPMs of cylinder are adjusted from the computer by feeding value here in the column of RPM. For example, we enter a value here and the RPMs are adjusted on the machine. The value 1 indicates the RPM 105, while the value 2 indicates the RPM 160. Similarly, this goes till value 4, while when we enter the value 5, the actual RPM of machine are 5. It is a ramp column, and we will discuss this column further in details. Command section. This section consists of several commands which are to be activated before or in between the knitting. For example, lubrication, feeder, jacks, latch openers, needle detectors, and cam activation, etc. Command plus denotes the activation of command, while command minus denotes the deactivation. This is the general layout from the software, that we enter a number in this column which is associated to a mechanical parts over the machine. For example, the command between 100 to 120 are for feeder 1. Similarly, 201 to 220 are for feeder 2, 301 to 320 are for feeder 3, and 401 to 420 are for feeder 4. And the commands less than 100 are general. For example, 66 number command takes dial jack outside, while 67 number command takes dial jack inside. Feeder commands can include the tuck feed, clear feed, etc. Yarn fingers activation. Yarn fingers are present in front of each feeder and consist different yarns. So we select the yarn finger which is to be activated for manufacturing of compression stocking, and this finger is activated on the machine by entering the finger number and feeder number here in the software. Yarn finger plus denotes the activation of finger, which keeps the finger down, while the yarn finger minus denotes the deactivation of finger, which keeps the finger up and doesn't feed the yarn to the needle. Step motor and cam height. A step motor is a mechanical part of a compression stocking machine which is present below each feeder. For example, there are four feeders, so four step motors are present below the each feeder. A step motor value is used to adjust the height of a cam which makes a specific stitch. For example, the minimum height of 90 is needed to form a knit stitch. So here value 25 denotes that the tuck stitch is being formed, while 155 denotes the knit stitch. It is a step motor diagram. Feeder or furniture. A feeder column is also present in the software which adjusts the rotation of furniture with respect to the rotation of cylinder. Here the value is entered in the value column which adjusts the value of rotation of furniture with respect to cylinder. For example, if value is 1, the furniture will take up at 1 rotation along with the 1 rotation of cylinder, or if their value is 95, the furniture will take 0.95 rotation along with the 1 rotation of cylinder. Damages due to wrong commands. Damages are always expected in the computer controlled machines because a computer software doesn't know the physical situation of the machine and it blindly executes the command on the machine, which can cause the damage to a piece being manufactured on the machine or to the mechanical parts of the machine. We will discuss some of the major damages which could occur on compression stocking machine due to wrong command in further slides. Wrong yarn finger selection. This damage is associated with the production of machine. For example, if we have to select a finger but we have selected a wrong finger with no yarn, then there will be a damage in stocking. Or if we have selected a finger with a wrong yarn which is not required in the stocking, then the stocking will also be damaged and it will affect the production of machine. Cam position and needle butt breakage. There are three positions of cam: plus 1 and 2 in forward horizontal direction. Plus denotes the active position, 1 on one position and 2 cam on second position, while there are four types of needle butts present on the machine, and it considers that when we change the position of cam, the needle of shorter butt should be present in front of cam, otherwise the butt breakage can occur. Let's see this in details. Here it can be seen from the figure that it is a longer butt needle than shorter and at the end shortest. So if we shift the position of cam from plus to 2 position while the long butt needle is present in front of cam, then the butt will collapse with the cam and butt will break. So it is considered that when we change the position of cam, the shorter butt needle should be present in front of cam so that command can be easily executed without any damage. Ramp value and mechanical damage. Ramp value indicates that in how many steps our command will reach to our next point. For example, here ramp value 8 indicates that after taking 8 steps the value of rpm will be 1, which is 106 at backend. So if our machine is running at low speed and we want to shift machine on higher rpms and we hadn't entered any value of our ramp here, then our machine will consume all possible energy and it will take the cylinder to the required rpms, and due to this, the machine will experience a jerk, and this jerk can damage several mechanical parts of machine. For example, bearings present under cylinder can start damping due to sudden load, or machine needle and cam should also be damaged. Conclusion. Compression stocking machine is a fully computer controlled machine and all the commands can be easily fed through computer into machine, which makes it efficient, and this is a plus point that we can change the machine parameters on our fingertips just in seconds due to the computer involved in the operation of compression stocking machine. The second point is that during execution of commands, if machine's actual situation isn't justified, it can cause several damages, including the breakage of mechanical parts. So it is necessary that before we execute any command on the machine, we should know the actual physical situation of machine at that time, so that the physical damages on the machine could be avoided. Here are the reference sources from where the information has been collected, while other data has been taken from the lectures delivered by teacher and the course material. Thank you. For queries, please contact on the provided email address. Allah Hafiz.